So the first thing I want to create is a smoke simulation, the large-scale smoke simulation. What is the main problems we will have when we create a large-scale smoke simulation? Well, the main problems is the RAM and CPU consuming stuff, because the bigger container we're gonna have, the more voxels we should use for simulation, more RAM, more time, more render time, etc, etc, etc. At this computer, I had just an 8-core, the old one FX 8650 AMD, and have 32 gigs RAM. So when I begin to work with this lesson, well, actually, I want to create just a scene to try to create a large-scale smoke simulation, and I have a task. Okay, how I can do this in my computer? I create a lot of different lessons, and mostly I create lessons when I have a free time, or when I have a free time for my computers. I have some computers at home, and when I work on some projects, I have free 1 or 2 computers, and I prefer to make some different type of simulation when I have just a free time. So you can, spend like months to create a simulation. It doesn't matter, because when I have a work and I don't have too many free time, I just can spend like a few hours per week, or like an hour per day to correct my simulation, to fix something inside of scene and play simulation again. So it's not like a task. I should create the scene like about 1 week. Okay, sometimes when I have more time, I will create the scene like about 1 week. When I have less time, I can spend like a month or 2 months to get a proper result for this scene. So it's not, I don't have a limit in timing. I don't have a plan where I want to finish this lesson. I have a free time, I work on this scene. I don't have a free time, then I will work on this scene a little bit later. But I have some timings, and for me, my time unit is night. When I create a simulation, the smoke simulation, fire simulation, something like that, the liquid simulation, I have one time unit is night. When I go to sleep, I begin simulation, and when I wake up in the morning and I see that, okay, like 80% of my simulation was done, I can see a result and I like this result. Okay, I can wait till the dinner to finish the simulation. So that's good. That's pretty enough. But when I come in the morning and I can see that it passed just 20% and it's take like 1 hour per one frame, yes, I have maybe like months to finish the simulation. I have such resources, I have such time, but it's not useful for a lesson. I don't want to tell you how to create a simulation and spend like a month for this. I need to create a simulation which we can use in production pipeline, when we can, spend like a day for sim, like a few days, depending on the result you want to get and depending on the hardware you have. So we can't wait a week, especially when you work at home and you have a very big limit in resources. Like I had like 32 gigs. Okay, I can't create simulation which will have which will consume more than 32 gigs RAM. I can't do this. I don't have such time. So there's always a limit. So when I begin to create this lesson and I create a huge smoke simulation, I wake up in the morning and I see that one frame was calculated. It was like about 47 frames done. It's not bad, in fact, 47 frames, like a few seconds just for one night, but the last frame was simulated about in 1 hour. So, and the smoke like was in this area. Well, I mean, this like about 10 meters high, or maybe 25 meters high. So it's not a big scale. And I understood that, okay, if I left the simulation till the end, I'm gonna spend too many times, 1 hour per frame, 2 hours, 3 hours, because the simulation will be bigger and bigger. So I stop the sim and try to find the proper way to make this smoke simulation with, to find another way to create the simulation with nice simulation time. So I decide to make my simulation not from huge one area, and I want to separate this area into the parts. And you can say, okay, this idea is not a very new idea. Sometimes we can create this, but I want to show you the automatic process using the top network and clusters for creating, to break the simulation into a part, simulate the huge smoke, break into a parts, simulate one after another one, and then combine them into one huge wall of the smoke. And I don't want to spend a lot of time for this. So let's try to find out how we can do this. Let's set up geometry. I want to add a source from a smoke. Now let's call this, fire source, because I want to create and the fire and the smoke. All right. I want to enable my ship to better understand when I want to put my elements here. So let's make a grid. Let's make a grid, and this grid should be very long, like make it 100 meters, about maybe 25 meters here, should be like there. And I want to copy parameter past the columns, copy this, space value of reference, so I can double number of polygons. So it's very useful if you want to change the size of this grid. There's always will be the proper polygons, the square polygons or primitives. Now, this is my plane where I want to put my emitter, my source. The fire should be somewhere from this area. But what I really want to do, I want to create I want to paint to make some areas, not uniformly. So let's go to create attribute paint node. And select this guy, and holding a shift button, we can apply a different scale for our point here and try to draw some lines. So with these lines, what I want to do, I want to create a randomly, places on this surface to create a non-linear result. I don't want to create a smoke just, with a straight line. I want to make the area where we have a smoke closer to the ship or far away from the ship. So I will draw this stuff. Somewhere like here, and then bigger, like some parts over here, and draw there, something like that. So, and as we can see, what we have as a result, we have the mask attribute. So we create a float attribute called mask. So it's not just painting and create a color. We create the mask attribute. You can see that when I press somewhere on this area, we'll lose our image. But now inside of geometry, we can see that we have some mask attributes, which can show us which points have this attribute, which points doesn't have this attribute. So basically, when I add a blast node, and inside of this blast node, I can say if my mask attribute is, I don't know, like mask equal to 0. Let me choose points. You can see that we have just all those points which I select with the pen, where I draw the image, where I draw those lines, I have just those elements. All right, The next thing is I want to use this surface to add a little bit of noise, okay? Because I don't want to fill the whole surface with the smoke and fire. From this area, I want to select some parts, some elements to create a nice noise for the source. So I add the attribute noise. In older version of Houdini, I prefer to use like attribute warp with some noise, but in this case, what I want to do, I want to set that I have the mask attribute, and I want to add the noise to this mask. So this is a float channel, float attribute. So I choose 1D and use multiplicative mode. All right. So I can't see the noise here because I can't visualize my mask attribute. So to better understanding what we are gonna have, I want to add a scatter node. I will apply the points just where we have the mask attribute. Okay, so now we have more or less better representation where we should have the mask attribute. So increase the amount of points, maybe to like 100,000, something like that. So with the attribute noise, I want to use the different noise noise type, sparse conversion, and press animate it. Oh no, I don't want to animate my noise. I just want to leave it static and make a remap. So now with the remap option, you can see that now we have just some small areas where we have points, and we have some areas where there's no points. And those areas where our mask attribute is a 0. Maybe I should have a little bit less minimum amount. So with the remap option, we create like a range between -1 and 1, and multiplicate those values to my mask attribute. And here what I have, I definitely want to use the bigger element size to have the bigger areas from my noise. Maybe stretch a little bit on the axis. It's looking pretty interesting. And what else I want to do? I just want to make a little bit more areas with the, like here, something like that. You can choose minimum to 0 in case we want to remove all attributes which are below the 0. Okay, so now we have a scatter, and I'm gonna use those points for emitting the fire. Okay, so I have the points, and what I want to do, I want to create the fuel from these points. So I'll go to attribute wrangle, come on. Yeah, we can use like pyro source or something similar to this for creating a nice source for our fire, but in this case I just added fuel, add fuel. So using this attribute wrangle, what I want to do, I want to set the burn field. The thing why I want to add a burn field is I'm going to create a sparse mode for the simulation. And we have a smoke, the large smoke simulation, and in this case I want to add some wind to make a movement for the smoke, like with some angle. We're going to have a lot of empty space in our container. So the sparse mode allows us to avoid such, unuseful amount of volume, and we will create in cache simulation just in those areas where we have some information, like a flame or the smoke. So, well, we can use a fuel, we can use any attribute we want. So we create the burn attribute based on the mask attribute, okay? So in this situation, if we look on geometry spreadsheet, we can see that we have the burn attribute. There is a different option, there's different parameters, different values for the burn. So it will create an additional noise to our, our source, because the more random stuff we have, the better. So I don't want to apply like 1 for all my points. I will apply the same amount, the same amount like in mask for our burn attribute. So the bigger amount inside of mask point has, the more burn attribute we're gonna have them. So the same stuff with the temperature. Temperature, it should be like a burn, or the mask, it doesn't matter. So we have the same attributes. And what else? Well, for the start, let's add our attribute rasterize volume from attributes. Let's add a source. So I want to convert my burn field, temperature field. So let's create them, normalize by climate coverage. Okay, and don't need any velocities. I guess that I will add some wind somewhere, so I'd increase the particle scale. But anyway, those particles are very big. Okay, so there's a few options we can decrease the particle scale. The one option is using this particle scale option here. The another one, we can use our attribute wrangle and say, okay, let's create a p-scale attribute, and all my points will have the size like 0.1. Okay, so now let's remove this. Let's make it back to 1. And this how my particles, my volume is visualized. So maybe, yeah, maybe a little bit bigger, like 1.5 should be fine. Okay, and I want to add some noise. We already have some, noisy stuff. If I remove this and type 1, you can see that we fill all our particles with the burn amount of 1. So there's a lot of burn. But when we apply our mask attribute, we can see that in some areas we have less amount of burn, in some areas we have more. So it will set for us some more different values. Less fire, more fire in some areas. And even more, I want to add the attribute noise for this. And with this attribute noise, I want to change my attributes from the burn and temperature. So I can copy just from here. And burn temperature, they both have 1D, so they are both float. So I choose signature 1D and multiplicative. And in this situation, I want to make this noise animated. And again, choose sparse convolution, remap. And I really don't want to go in minus, so I press 0 here. And you can see that we have a little noise here. So with the element size, I get that I will increase this element because we have a pretty small noise. So maybe like 3. And with the pulse duration, because we have a large scale theme, I will increase the pulse duration so our noise will change with the smaller speed. So we will spend 3 seconds to make one cycle for the noise. Alright, so that's it. Again, maybe I should add a minimum in case we have some negative values from here. We don't need to have those values if you want to rasterize our attributes. Okay, so with this volume, I get that we can send this simulation to the Pyro solver. So let's add a null object, and our source is ready. So let's name it fuel out. That's what we have, the proper nice source for our simulation.